Part D in Section 2.6 is called Miscellaneous Problems, and there's only one example here. I'm actually of the opinion that most of these problems are really the same kind of problem with different twists on them, if you will. They still require two sentences to be set up, a substitution to be done, and then an equation to be solved before answering the final question. This problem is remarkably like the coin problem and the interest problem that we did earlier. We're going to have one sentence that talks about the number of each kind of ticket sold, and a different sentence that talks about the value. If the number of adults' tickets sold is A, and C represents the number of children's tickets sold, then the value of all the adult tickets sold is 6 times the number of tickets. If they'd sold one ticket, this would be 6 times 1, or $6. If they'd sold 7 tickets, then they would have taken $6 for each of 7 tickets. 6 times 7. If C is the number of children's tickets sold, then the value of all the children's tickets sold is 4 times the number of tickets. Sell one children's ticket and it's 4 times 1. Sell 12 and it's 4 times 12 tickets. $4 for each of 12 tickets, or $48. So this is the value of adult tickets sold, and this is the value of the children's tickets sold. What I've done so far is look at the fact that tickets to a school play cost $6 for adults and $4 for children. I haven't done anything beyond that except to find the variables that I'm going to use. A is the number of tickets, C is the number of tickets, 6A is the value of tickets, 4C is the value of tickets. But now if I read on, I see that a total of 200 tickets were sold. A total of 200 tickets implies that the number of adult tickets and the number of children's tickets, when added together, is 200. The other piece of information we're given is that $940 was collected in receipts. In other words, the total sale was $940. That means the value of the adult tickets plus the value of the children's tickets added together is $940. Something to keep in mind as you're working is that A is the number of tickets, C is the number of tickets, and the total is a number of tickets. In this sentence, though, $6 times A tickets is a number of dollars. 4C is also a number of dollars. $4 per children's ticket is a total amount, a number of dollars, and 940 is also a number of dollars. So within each sentence, I'm working with the same units. But A is still a number of tickets. That A is the same as that A there. Now I have my two sentences. So what I'm going to do next is change one of the variables in this sentence, either the A or the C, to the other way that it can be written using this sentence. Let's just pick one. Let's leave the A as it is and change the way we write C. I need a different way to write C here. In previous examples, my first sentence was already in a form C equals or A equals, giving me an alternative way to write that variable. In this case, though, it's not ready for me to substitute. I can find another way to write C, but I need to do some algebra first. Now I can substitute C with 200 minus A. And I can carry on from there. It's worth noting that I could have solved this for A instead. And in that case, I could rewrite this sentence 6 substitute for A plus 4C equals 940. And A can be replaced with 200 minus C. Either one of these will work for continuing the problem. Let's do this version here. Distribution to get rid of parentheses gives me 6A plus 4 times 200 minus 4 times A equals 940. Combining like terms, I get 2A plus 800 equals 940. And subtracting 800 from both sides, I have 2A equals 140. Dividing both sides by 2 gives me A equals 70. If A equals 70, then I've sold 70 adult tickets. How many children's tickets have I sold? Well, if A is 70, I can replace this A with 70. 70 plus C equals 200, and subtracting 70 from both sides gives me C equals 130. So I should have A equals 70, 70 adult tickets sold, and C equals 130, 130 children's tickets sold. Let's see if it works the other way as well. Solving this problem instead, I get 6 times 200 minus 6 times C plus 4C equals 940. Combining like terms, I get 1200 minus 2C equals 940. Subtracting 1200 from both sides gives me negative 2C equals negative 260. Now, C is stuck to negative 2 by multiplication. So to unstick it, I need to use division. Dividing by negative 2 guarantees that this whole number divided by itself is 1. And I get C equals negative divided by a negative is a positive, and 260 divided by 2 is 130. C equals 130. That matches what I got the other way I did the problem. Substituting C equals 130 into this equation gives me A plus 130 equals 200. And subtracting 130 from both sides gives me A equals 70. And that matches what I got the last time as well. So it doesn't matter whether I solve for A and then substitute in for A, or solve for C and substitute in for C. What does matter is that once I've found one of my variables, I have to remember to resubstitute into the other equation to find the other one.